So guys, we are solving one more problem of friction. So the question here is, find the force P just required to slide the block B in the arrangement shown in the sketch. So you have a sketch here, okay? The sketch is here. So you can see like there is block A and block B, okay? And it's been tied with the string to one of the support, and they are also asking you the tension which is developed in the string, okay? And also they have given the loads on block A and block B. That is, on block A it is 500 newtons and block B it is 1000 newtons, and coefficient of friction is 0.2 for all the surfaces, okay? So how can we solve this? Here is the sketch. So here block B tends to move towards left side because there is a force P which is trying to move the block B towards left, and block A tends to move towards right with respect to B. So now let T be the tension developed in the string, okay? They are also asking you the tension in the string, okay? Here you can see. So let us consider block A here. Fine, this is block A, and this is the free body diagram of the block A, okay? We have released it from all the supports. That is what we call it as a free body diagram. So now what all you can see in the block A, there is 500 newtons, the weight of the block A, and because of the weight there will be a reaction developed, okay? And you can see the tension force which was tied to this string, okay? And this can be resolved as T sin 30 and T cos 30 depending upon the horizontal and vertical. Since the angle is made with the horizontal, so the vertical component will be sin 30, horizontal component will be cos 30. So now let us see what was the coefficient of friction. It was 0.2. Mu is 0.2, which is equals to F by R. And can we write F is equals to 0.2 R1 because R is equals to R1 here, okay? Why we are specifying it as R1? Because we will be getting two reactions, because one at the bottom of the block A and other will be at the bottom of the block B. So we are like differentiating between R1 and R2. So whatever the reaction that is developing at under the block A, will call it as R1, and whatever reaction that develops at the bottom of the block B will be the R2, okay? So now what we can do, we can start the problem. So sigma h is equals to 0. Now what are all the horizontal forces you can find here? See, you have F. So how did you get this F? So this F is the friction. Now I just want to tell you something. When a tension T is acting in the rightward direction, what it does, it tries to pull the block towards the right, okay? So along which direction the motion trend will be? The motion trend will be towards right. What is this motion trend? Along which the body is intended to move, okay? That is the motion trend. And always remember, the friction will act in the opposite direction to the motion trend. It is always, okay? It is a fixed fact. Next, so this is F, okay? This is friction. So now come down to our equation, horizontal forces minus F, since it is acting leftwards, and plus T cos 30, okay? This is our equation for horizontal forces. So now we have replaced F by 0.2 R1, which is written here, okay? 0.2 R1 plus T cos 30. So R can be summed up as T cos 30 divided by 0.2. Now this is equation 1. Now coming to summation of vertical forces. You have minus 500 which is acting downwards and plus 4.33 T. Now what is 4.33 T? The 4.33 T is the value of this R1, okay? How did you get this? You got this by solving this equation, Okay, so R1 is equals to T cos 30 by 0.2 will give you R1 is equals to 4.33 T. Okay, that value I have replaced here. Fine. So plus T 0.5, sin 30 value is 0.5. So what is the total value we got now? 4.83. We have to add this. 4.83 T is equals to 500, hence T is equals to 500 by 4.83. Now we have got T is equals to 103.51. And so this is the tension that is developed. Now R, okay, R is 103.51. We have substituted the value of T in equation 1. Okay, so we have substituted there after substituting we got R is equals to 448.24. okay, this was just on the block A. Now coming to the block B. Now what all forces you have at block B? See, the weight of the block B is 1000 newtons from the question. Okay, here you have the question. So the weight on the block B is 1000 newtons. And whatever reaction you had at A, for example, our reaction at A was like this. Okay, whatever, this is A. Now whatever reaction was there at the bottom of the block A, that will act as the load on the block B. So this will be R1. Fine. And now how was the friction on the block A? The friction was towards the left. And now in which direction your block B will move? Your block B will be moving towards left. Okay, because it is being pulled by force P. This is the motion trend. What is motion trend? It is the direction along which the body is intended to move. Okay, so whatever direction you had obtained on the block B, under the block B, the exact opposite direction, this is block B, and the friction will be acting in the opposite direction for block B, because they both are moving in the opposite direction, hence the direction of friction will also change. This is mu R1, that is equals to F. So mu is equals to F by R1. So your F happens to be mu R1. That is what I have written here. Here, because of these loads, there will be reaction developed, and as I said earlier, this will be R2. And if the motion trend is towards left, the friction will be towards right. So this will be mu R2. This is F1, this is F2. So mu is equals to FR2. So F is equals to mu R2. Okay. So these are all the forces which are expected to act here. So you know mu is equals to 0.2. So now let us solve the problem. Summation of vertical force is equals to 0. Okay. So what are all the vertical forces you have? You have R1, which is minus. You have minus 1000 also. And plus R2 you have. And that's it. No other forces are acting. These are the three forces which are acting vertically. So E should be equated to 0. Now what is R1 you have obtained? R1 is 448. So you can specify here. This is R1. Okay. In the previous page, R1 448. 448.24 minus 1000 plus R2 is equals to 0. Now you can sum up. R2 will be 1448.24 newtons. Now next, summation of horizontal force is equals to 0. Now what are horizontal forces? You have minus P, which is acting leftwards, and you have these two forces, friction forces. So both are acting towards right. We can directly take as is equals to 0. So minus P, now substitute those values guys. So mu is 0.2. What is R1? R1 is 448.24. Okay, plus 0.2. What is R2? 1448.24, which is equals to 0. So if you solve this, if you calculate this, you'll be getting P is equals to around 379 newtons. Okay, so this is how you need to solve the problem. Okay, this was regarding the problem.